So, good morning. Our study concerns the use of marble crushed sand in cementitious materials. During the processing of marble, large quantities of waste materials are produced, and more specifically, marble slurry and broken marble pieces. Those marble products, those byproducts, can be utilized in the construction industry because of their compatibility with cementitious materials, and could offer significant economic and ecological advantages, such as reduction of CO2 emission, reduction of consumption of fuels and power, and of course, lessen the usage of raw materials that are in great demand. So, in this study, we investigated the effect of partial substitution of natural aggregates with waste marble crushed sand on the rheological properties of mortars, and as well as we investigated the effect of waste marble crushed sand granulometry. We use typical equipment for the preparation of mortar mixtures according to relevant standards, and we used two standard methods for the measurement of fresh properties of mortar mixtures, namely the flow table test and the Vicat test. We examined the granulometry of the natural sand that we used as reference sand, and the granulometry of the crushed sand we received from the plant. We used standard sieves and a vibrating sieving machine. The same equipment we used to remove the finer fractions from the crushed sieved sand, lower than 125 microns. So these are the gradation of the three sands we used. Here in gray, it is the natural sand we use as reference. The blue is the gradation of the crushed sand as we got from the plant. And the light blue one is the gradation of the sieved crushed sand without the finer part. We prepared several mixtures. This is the one, the reference mixture with 100% natural sand. This C25, C50, and C75 are the mixtures when we replaced 25%, 50, and 75% of with crushed sand. And this CS25, etc., is the sieved crushed sand without the finer part of the sand. You can see that we use the same water in all mixtures. So the result for the flow table test show that, as you can see with the blue line, this is the flow values we got for 25% replacement, 50% replacement of natural sand, and you can see that the workability is even improved compared to the reference mixture. When we tried to replace 75% of the sand, the mixture was not workable at all, as you can see in the picture. When we used sieved sand, the workability of the mixture was very similar to the reference one, and even improved a little bit, and we got a very good workability even at 100% replacement. So for this is the result we got from the Vicat test. Here you can see the light blue is the setting time of the reference mixture with the natural sand, and this too is the 25 and 50% replacement with the crushed sand, you can see that although the final setting time is the same, the initial setting time starts about 1 hour earlier. And here you can see when we replace 75% of the sand that setting time is much earlier and the method is not workable. When we used the sieved crushed sand, here you can see the reference mixture and as a reference, and here you can see the 4 replacement ratios. So you can see when that all, in this case, also all mixtures exhibited earlier setting time compared to the reference mixture with the natural sand. Setting starts about 1 hour earlier and is completed also 1 hour earlier than the reference mixture. So concluding, the replacement of natural sand by crushed marble aggregates up to 50% leads to the improvement of fresh mortar properties. Further addition of crushed sand leads to severe reduction of workability. When sieved crushed sand was used, the replacement ratio could be raised up to 100% without any depreciation of the ferrous mixture workability. And the main disadvantage shown by Vica testing is the earlier setting time measured when crushed aggregates are used and should be accounted for, and that should be accounted for in practical applications. Thank you very much for your attention.